Lecture 3.7, Implicit Differentiation. This is, of course, Niagara Falls that straddles the border between New York and Canada. These are the American Falls on the American side. This is not a function, but it would still be nice to be able to find the slope. One of the basic rules of algebra is what you do to one side, you do to the other side. Here we're going to take the derivative of both sides. We take the derivative with respect to x, and we get 2x plus 2y dy dx equals 0. Notice that when we took the derivative with respect to x of y squared, because it was the derivative with respect to x, not y, we needed to use the chain rule. Also, the derivative of a constant is 0. Now we can subtract 2x from both sides. And divide both sides by 2y to get dy dx by itself. After we cancel the 2's, we see dy dx equals negative x over y. So if we know x and y, we can find the slope anywhere on the circle. Here's another one. 2y equals x squared plus sine y. Now this one can't be solved for y. But we take the derivative of both sides with respect to x, and we get 2 dy dx equals 2x plus cosine y dy dx. Notice again that we use the chain rule in two places. So we move all of the dy dx terms to the left side and factor out dy dx as a common factor. Then it's a simple matter to divide both sides by 2 minus cosine y to solve for dy dx. Here once again we have an expression for the derivative in terms of x and y. This technique is called implicit differentiation. The steps are: 1. Differentiate both sides with respect to x, and 2. Solve for dy dx. It's called implicit differentiation because we can't solve for y and then take the derivative. Example, find the equations of the lines tangent and normal to the curve x squared minus xy plus y squared equals 7 at -1, 2. We need the slope. We can't solve for y, so we use implicit differentiation to solve for dy dx. So we take the derivative of both sides with respect to x. Notice because we have a product, neither one of these are constants. So because we have a product, we have to use the product rule. Now we clear the parentheses, collect the dy dx terms on the left side, and move the other terms to the right side, and then solve for dy dx, giving us an expression for the slope in terms of x and y. So the slope is m equals 2 minus 2 times -1 over 2 times 2 minus a -1. which we got by putting in the values for x and y. Simplifying, we get the slope is 4/5. Now that we have the slope, we already have the point. So for the tangent, we can use the point-slope equation. And we get y minus 2 equals 4/5 times x plus 1. Or y minus 2 equals 4/5 x plus 4/5. Or finally, y equals 4/5 x plus 14/5. Now to find the normal equation, we use the same process, but we need a new slope. The slope is going to be the opposite sign reciprocal of the original slope. So using the point-slope equation again, we get y minus 2 equals negative 5/4 times the quantity x plus 1. We eliminate the parentheses and solve for y. So there's our normal equation. Higher order derivatives. Suppose we want to find the second derivative for the curve represented by the equation 2x cubed minus 3y squared equals 7. First, we take the derivative of both sides. Notice this time I used the y prime notation instead of dy dx. And I solve for y prime. I get y prime equals x squared over y. So the second derivative is the derivative of the first derivative. So taking the derivative of y prime using the quotient rule, I get y double prime equals 2x times y minus x squared y prime. Notice once again we need to use the chain rule over y squared. Or y double prime equals 2x over y minus x squared over y squared times y prime. But we know what y prime is, so we substitute y prime back into the equation. So now y double prime equals 2x over y minus x squared over y squared times x squared over y. And we simplify to get y double prime equals 2x over y minus x to the fourth over y cubed. Now let's do one on the TI-nspire. Once again, we'll use the equation 2x cubed minus 3y squared equals 7, and we'll find the second derivative. On your calculator, press Catalog I and select Implicit Differentiation. Now in this screen, the calculator tells you what you need to enter. So we'll need to enter the equation, the independent variable, the dependent variable, and if we want a derivative other than the first derivative, we need to enter the order. So in this case, this is our command, impdiff 2x cubed minus 3y squared equals 7, comma, x, which is the independent variable, then comma y, which is the dependent variable, and then 2, because we want the second derivative. Then just press enter, and there's our answer just as quick as that.